Hello everyone, this is part 4 of 11.3 and 11.4. Part 4 of exponential functions and logarithmic functions. Turns out the previous video only recorded 8 minutes. That video only covered, I think, problem 1 and 2. So I'm going to talk about 3 and 4 in this video. Problem number 3, logarithm with base 2 of 2 to the power of -5 equals x. The equation is in the logarithmic form. One way to solve this equation is to convert it to its equivalent exponential form. So base is 2. 2 is raised to the power of log. Log is x. Equals the anti. The yellow part, the whole thing, the yellow part, that's the anti. Equals 2 to the power of -5. And then we are looking at an elementary exponential equation. They have the same base. Blue equals blue, right? And they're supposed to have the same exponents as well. X equals -5. That's how do we solve this equation. Number 4. Actually, I could rewrite this number 4 here. 2 to the power of log with base 2, 64, equals x. The given equation is 2 to the power of whatever this part, that's the power, that's the exponent. 2 to the power of the green part equals x. So the equation is in the exponential form. One way I can solve this equation is convert the equation to its equivalent logarithmic form. Let's try that. Log with base 2. 2 is the base, right? What's the anti? Anti is x equals log. Remember, log is on the shoulder of base. Log is log with base 2, 64. After the conversion, we have the equation we have an equation, have a single logarithm on the left, have a single logarithm on the right. And the base are the same. Then should they have the same anti? X equals 64, right? Earlier, we had the problems we converted from logarithmic form to exponential form. In this case, we convert the equation from exponential form to its equivalent logarithmic form. It works very well. Method 2, another way to handle this problem is we have x equals 2 log with base 2, 64, right? So I'm gonna explain in this way. Let's say you have 64. If you plus 2 minus 2, what do you have? Do you go back 64? Because minusing 2 reverses plusing 2. Same idea, if you have a 64 in the beginning, you multiply by 2 and then divided by 2. You would have a 64 again, because dividing by 2 reverses multiplying by 2. Same idea, if you have 64 in the beginning, you apply the logarithmic function with base 2, and then apply the exponential function with base 2. You would go back 64, because the two functions reverse each other. In previous videos, we talked about logarithmic function is the inverse of an exponential function, right? This is an exponential function with base 2. This is a logarithmic function with base 2. They are inverse of each other. So if in the beginning we have 64, and then we apply logarithmic function with base 2, and then we apply exponential function with base 2, we will go back 64 because exponential function with base 2 reverses logarithmic function with base 2. Yeah, try to understand that. With that understanding, the solving of this equation would be a lot easier. Okay, so let me see what else. In my notes, I have another example. Example 3 is to require you to apply a calculator to look at the graph for those functions. For those, some of them are exponential functions, some of them are logarithmic functions. I'll leave that part for yourself to figure out. Okay, so section 11.3 and 11.4, exponential functions and logarithmic functions. We have 4 parts, short videos. I hope you can rewatch those videos, really get the contents. If you have any questions, please feel free to make an appointment with me. I hope to see you soon in Zoom. Thank you for watching.